Welcome to the VMware Telco Cloud Platform RAN demo. Powered by Dell EMC PowerEdge servers and Intel FlexRAN, Telco Cloud Platform RAN helps service providers modernize their RAN with simple steps. Telco Cloud Platform RAN includes VMware Telco Cloud Automation to automate the instantiation and provisioning of RAN platform and VMware Tanzu Kubernetes Grid through automation, all while managing the lifecycle of vRAN functions. Utilizing Kubernetes worker nodes, Tanzu allows vRAN functions to be containerized and deployed on RAN sites, while VMware's ESXi provides a flexible and future-proof hypervisor layer. As a result, service providers can modernize their RANs by virtualizing vRAN functions now and disaggregating them in the future. With this demo, we will showcase how easy it is to instantiate and provision the horizontal RAN platform across RAN sites with 4 simple steps. 1. Build new Telco Cloud RAN-ready sites across RAN. 2. Deploy Tanzu Kubernetes clusters. 3. Onboard Altiostar's RAN functions on Tanzu Kubernetes clusters. And 4. Run non-RAN workloads on the same RAN-optimized platform, allowing service providers to monetize their newly modernized RAN. We will now examine one setup scenario for service providers. By utilizing infrastructure automation, the Telco Cloud software stack will be instantiated and provisioned. Automating the deployment of RAN sites is crucial for achieving scale. Each of the Telco Cloud Platform RAN sites is powered by Dell EMC PowerEdge servers and Intel FlexRAN architecture for optimal performance. First, let's see how we can automate instantiation and provisioning of the platform using its infrastructure automation capability. Automation can be initiated through a pre-configured CI/CD pipeline to help orchestrate deployments more easily, transparently, and efficiently. The CI/CD pipeline initiates the deployment of a central site before deploying regional edge sites and cell sites, using Telco Cloud Automation's infrastructure automation capability. We start by validating the global settings applied to every site. Software appliance configurations, license keys, locations of images, and other security parameters. Let's dive deeper into this site. You can see its configurations, provisioned hosts, and appliances. The Detailed Tasks tab displays all the automated actions performed by the system. Automation is crucial as it allows deployment times to be significantly shortened. Regional and edge sites are provisioned in the same way. You can see the process here. Now that the edge site is successfully deployed, a single cell site is added to the cell site group for this demo purpose. As seen from vSphere Client, this site is managed by the previously provisioned edge site. Next, let's move on to Tanzu Kubernetes cluster deployment using Telco Cloud Automation's CAS automation capabilities, where vRAN functions will be hosted. Let's start by bootstrapping a base cluster that contains a set of extensions and nodes configurations over the platform. In order to deploy a Tanzu Kubernetes cluster, a cluster template needs to be created. The template can be a great tool to deploy multiple clusters consistently and across multiple RAN sites. To begin, let's create a management cluster template using the CAS infrastructure. Add Kubernetes Template Wizard. Provide template details such as cluster type, Kubernetes version. Next, define cluster configuration and extensions. Provide master node configuration by providing control node VMs, labels to group networks together. Use worker node configuration to create a node pool. Finalize the details and add the template for future use. Next, let's create a workload template. Provide cluster details such as cluster type, Kubernetes version, container network interface, CNI. Here we use Antria and Multis. For container storage interface, CSI, let's use vSphere CSI. Next, provide the master node and worker node configuration details. Finally, review the template details and add it to the template catalog for future deployment. Now that we have the templates created, let's deploy our new Kubernetes cluster onto the platform. To do that, let's return to the Cluster Instances inventory and choose Deploy a Kubernetes cluster. Let's start with selecting where to deploy the cluster by using the template we just created. Built-in automation and auto-discovery mechanisms provide appropriate values for all cluster resources by correlating template requirements with available platform resources. This dramatically simplifies configuration process. All it needs is the network assignments for the master and worker nodes. Finally, review the configuration prior to deploying the cluster. Let's deploy. The workload cluster deployment follows similar steps. By inspecting the cluster instances inventory, we can verify that the cluster is successfully deployed. As seen here, we have deployed an Altiostar workload cluster. Worker nodes for CUCP, CUUP, and DU are also deployed successfully. Now that the platform has been deployed and provisioned, let's onboard and instantiate Altiostar's vRAN functions. Let's onboard Altiostar network functions by uploading the CSAR package. The catalog allows us to repeat the deployment process for any vRAN functions. Here are the configuration details for Distributed Unit, DU, and CUCP. The Telco Cloud Platform RAN provides new extensions that facilitate the creation of vRAN functions while automating Kubernetes node deployments and VM configurations. When you onboard a virtualized RAN function, you can programmatically adjust the underpinning platform availability and resource configuration based on the function's requirements. This programmability and customization are referred to as late binding. These late binding capabilities enable you to dynamically move DU and CU resources on demand, allowing you to improve resource utilization or add additional resources on demand. In case of DU, customization is quite extensive, ranging from OS kernel modifications to precision time protocol setup to SR-IOV. Late binding makes deployment far simpler, especially considering that hundreds and thousands of instances are involved in the RAN. The Altiostar's vRAN functions such as CUUP, CUCP, and DU are now onboarded into our catalog. Once all the prerequisites have been met, let's instantiate and provision them at required site. This is where late binding comes in handy, as it programmatically adjusts the Kubernetes nodes and VMs based on the specific requirements of the vRAN functions. We instantiate other vRAN network functions following similar process. As shown here, vRAN functions are instantiated. Since Telco Cloud Platform RAN is a horizontal platform, we can host non-RAN workloads, such as MEC, or applications on the same platform alongside vRAN functions. To emulate the deployment of a MEC application onto the same platform alongside Altiostar's CU, here we use testnf. Add a new node pool for MEC to the previously deployed Kubernetes cluster. The onboarding and instantiation process for this MEC application is identical to that of Altiostar's CU. With just a few simple clicks, the instantiation is successfully completed. As seen here, both vRAN and non-RAN workloads can be deployed on the same RAN-optimized platform, allowing service providers to monetize their newly modernized RAN. In this demo, we showed how to deploy Telco Cloud Platform RAN and Tanzu Kubernetes. Altiostar's vRAN functions were then deployed on the platform. Finally, a MEC application was deployed alongside the vRAN function. With automation, all can be done in a few simple steps. Here is your path to modernizing your RAN and monetizing it.